Okay, here in this video, we're going to focus on factoring our polynomials. So remember, we have four methods. We talk about finding the greatest common factor, the difference of squares, trinomials, and what happens when our trinomial maybe has a leading coefficient, and we need to work with that. So let's get started with GCF. Remember, it's just greatest common factor. I have 21c minus 12, so what can I pull to the front? Well, we'll divide into both of them evenly, and that would be, 3 will go into both of those. So if I put 3 in, if I take a 3 out, that would leave me with 7c and minus 4. Okay, number 2, I have x6y plus 8x squared y. Well, 1 and an 8, so I don't have a coefficient to take out, but I do have an x squared and an x to the 6th. Take out the smallest one, it'll be in both of them, so I'll take out an x squared and a y, so I'm going to take out a y. What does that leave me with? Well, it leaves me with x to the 4th plus 8. Number 3, 75a squared b to the 3rd, c minus 30, ab second. So I need to think what will go into both 75 and 30. My first thought is 5, but I'm wondering if something bigger will go in. I know 10 won't. I know 15 goes into 30. Yeah, 15 goes into 75, so I'm taking out a 15. I have an a squared and an a, so I'm going to take out the a. B to the 3rd, b to the 2nd, so we'll take out b to the 2nd. C and no c, so I can't do that. So what does that leave me with? Well, 75 divided by 5, or 15, 75 divided by 15 is 5. A squared, I took one of those a's out, so there's one a left. I took 2 of the b's out, so there's one b left. And that c is still there. Minus, well, 30 divided by 15 is 2. I took the a out, and I took the b squared out. So this would be my GCF coming out. In number 4, I'm looking here for a difference of squares. Remember, it only works for binomials, and it only works if there's subtraction. So w squared minus 64, yes, squared, that is a perfect square. So we could open this up, and we're going to say, well, that means I can have w, well, the square root of 64 is 8 plus 8, and w minus 8. 5, 9k squared minus 1. There is a difference. It is a binomial. 9k squared is a perfect square, and 1 is a perfect square, so I can do this. This would be 3k plus 1 and 3k minus 1. In 6, again, I'm looking to make sure m squared, n squared, subtraction, 4 and 81 both work. So let's go ahead and break this up. This is going to be 2m plus 9n, and it's going to be 2m minus 9n. Now, looking at trinomials. Now, the important thing about these trinomials here for 7, 8, 9, if you notice, all of their leading coefficients are 1. So these are the ones we like to work with, because really what we're looking for are two numbers that multiply to c and add to b. So what two numbers will multiply to positive 30 and add to negative 13? I'm thinking 3 and 10. Negative 10 and negative 3. Okay, y squared minus 3y minus 40. Again, I'm looking for two numbers that multiply to negative 40 and add to negative 3. And because it's a negative 40, I know that I'm going to have a positive and a negative. So let's think. I'm thinking 8 and 5. So 3 is negative, so it would be a negative 8, positive 5. Negative 8 plus 5 is 3. Negative 8 times 5 is negative 40. The number 9, I have a squared plus 12a plus 36. Again, two numbers that multiply to 36 and add to 12. That would be 6. So a plus 6 and a plus 6. Now, I could rewrite that. I could call that a plus 6 and then put a square there. So I think those are the three that you're most comfortable with. And then we have number 10, 11, 12. And the difference here is I have a leading coefficient. So what I'm going to do is I'm going to take the a times the c, which is 9, and I'm going to look for two terms that I can multiply to 9 that will add to 10, so I can turn this into a polynomial. So I'm going to start with the 3x squared. Now two numbers that will multiply to 9 and add to 10 would be 9 and 1. So I'm going to say, well, this would be 9x plus 1x, then bring down the 3. So really what we're doing is we're just splitting this into two pieces. And now that we have it in two pieces, we're going to set them into groupings. I'm going to start with the first one. Will anything come out of, or what GCF will come out of 3x squared plus 9x? And I can take out a 3x, which will leave me with x plus 3. And if you notice, I already have x plus 3 here, but I need to bring something out, so I'm going to bring out a positive 1. I can always take that out if I need to. So x plus 3. And then I can rewrite this. So this is going to be 3x plus 1. Remember, we're just going to put together our two GCFs, and then we're going to keep the common factor of x plus 3. Okay, number 11. This would make negative 24. So how am I going to divide this up? I'm going to start with the 12c squared. What two numbers will multiply to negative 24 and add to 5? Yeah, 8 and 3. So let's do plus 8 minus 3, and then I'm going to have the negative 2. So I turn my trinomial into a polynomial, and then we are going to group them. So the first two will group, and the last two will group. So I'm going to take out my GCF, which would be 4c, leaving me with 3c plus 2. Now I have negative 3c minus 2 in the next one, and I really need it to be 3c plus 2. So I'm going to take out a negative 1. And that will change those to positives. And now I can rewrite my problem. I'll have 4c minus 1, and I will have 3c plus 2. All right, and number 12, I have 4 times 7. So I'm looking for something that multiplies to 28 and adds to negative 16. We'll rewrite this. I have 4v squared. 28, huh? I'm thinking negative 14 and negative 2. Negative 14v, negative 2v. That would add to negative 16, and 14 times 2 is 28. So yes, that works. So I've turned my trinomial into a poly. Now we're going to group the first two, and we're going to group the last two. So we're going to take out the greatest common factor, which is 2v, leaving me with 2v minus 7. I notice I have 2v plus 7. I get a negative. Let's take out a negative 1, which would leave me with a positive 2v and a negative 7. There we go. So I would have 2v minus 1 and 2v minus 7. So that just kind of walks you back through each of our factoring methods.